Oh yeah. Yeah, at the same time, very satisfying. Yeah. Being like, I think sort of I think so. We were way less put together. Like we didn't have really any stuff.
Okay, you can take a look at the calendar with me. Today we're going to talk about angle sum and difference identities. We've seen it already. It's just our second time through. It didn't show up on the test, but you've seen it already. So I think the second time through, it should feel more familiar. Double angle identities. You already know how to do this. It's just presented with where problems are going to look a little different, but I feel like this is gonna be like review, okay? And we're just gonna have a short quiz over this next Tuesday. I don't think you'll have a hard time with this at all. Plus, we have Monday to review, and then we're just gonna take a short quiz on Tuesday. It won't be very long, which means that we can probably spend some time in the beginning, going over a couple problems before you even take the quiz. Okay, so short quiz Tuesday. Wednesday, Thursday, Friday, we'll continue with the packet, and then Thanksgiving break. Come back, we will do 2 days of review with calculators, and then we'll have a quiz that Wednesday. And then finish off the rest of the packet, 2 days of review. Final test is the 10th, okay? And after that, this is really the last grade in the grade book. So there's really, I don't have anything really for us that final exam week. Monday is a full day of class, normal day of class. Tuesday is 7th period final exams, which means that all the periods will be shortened. So, I'm just going to be working with students who are trying to make up recovery tests or trying to get their grade up to passing, or struggling, students with struggling grades. But, if you're, this may be the last day that we really do anything. Okay, so this last week is really not, for a lot of us, is not going to mean much. Okay, yes, question. No final exam.
So which classes do you have final exam?
I think there is no final exam category. I don't think there's final exam category for anything, but some teachers do give final exams as a way of as an optional final exam, but nothing. I don't think any final exam is required. There's no final exam category this semester, so I don't think you should have any final exams. So that's so right. I mean, we really have 3 full weeks of classes left before in the semester. Right. Quiz next week, quiz following week, and test. Okay. Any questions with our calendar?
So the Monday, regular like finals week on finals week, is that like a day off for everybody? Or
It's just going to be a study hall this day. I mean, I still have to take attendance, but.
they have to show up to school?
But don't you all have like certain remote days that you can take?
an asynchronous day.
That is a good idea.
Yeah. So yeah, there's that possibility. You can take asynchronous day. Okay, so let's look at page 2. Have your calendar, flip to the back of the calendar and you'll see the formula sheet as well as a unit circle filled out. So it'll be easy for us to reference as we work through these problems. Make sure I'm recording here. Okay. Okay, so what we're going to do here is, what we're going to do here is we're going to try to use sum of difference identities to find the exact value of each expression. Okay. However, we want to use values that are more accessible measures or radian measures that show up on the unit circle. So we know that we don't really recognize 13/12, right? 13π/12. But maybe we can think of two angles that add up to be 13/12 that are measures that we recognize. So let's just play with some numbers here. Don't worry about the pi. Let's just deal with fractions. So can you give me some possibilities of what numbers add up to be 13 that could potentially show up as, radian measures that we recognize? Give me some options. What numbers add up to be 13? Say it again. 7 and 6. Okay, so 7π/12. I don't think that quite works. 6π/12. That works. So that's a possibility, but didn't quite work out the way we want. Another option? 10 and 3. Yeah, I think that could work, right? 10/12 reduces to be 5π/6. Yeah, let's just try that. So I can think of this as 5π/6 plus pi/4. Okay. Are you guys in agreement there? Yeah. All right, 10/12 plus 3/12 equals 13/12. 10/12 and 3/12, 5π/6 and pi/4, they show up on our unit circle. So okay. Now let's look at cosine, the sum identity for cosine. Let's see over here, right? Okay, so we'll copy that down. Let me put a star next to it. That's going to be what we're going to be building off of. Doesn't matter which one you choose. Let's do 5π/6 for A and pi/4 for B. And then just replace all the A's and B's with 5π/6 and pi/4. All right, look on your unit circle. What's cosine of 5π/6? Remember, the x value is the cosine, the y value is the sine. All right, -3π/2. Sorry, -√3/2. Cosine of pi/4. √2/2. Sine of 5π/6, 1/2. Sine of pi/4, √2/2. Let's multiply across. This is -√6/4. Minus √2/4, right? We're multiplying each of these fractions. So now that we have common denominator, we can't make this √6 minus √2 is -√8. Okay, so these are kind of separate, but that's the best we can do. At least we have an exact value, even though the angle measure doesn't quite fit in our unit circle, we're able to represent in terms of measures that we do recognize. Okay, questions? Okay, let's shift over to tangent of pi over 12. So 1 over 12, that's a kind of a small number, right? So maybe let's think in terms of a difference. Can you think of two numbers that subtract to be 1? That could end up being measures that we recognize, right? Because we don't recognize pi over 12, but maybe we can think of two measures that subtract out to be 1 over 12. 4 and 3, okay, let's try that. Okay, so that works, right? 4 pi minus 3 pi is 1 pi over 12. And these are both measures we recognize. This is pi over 3, and this is pi over 4. So we can write this out as tangent of a minus b. Let me write that rule above. Okay, I'll let a be pi over 3, and I'll let b be pi over 4. Any questions so far? Okay, so over to the right side, replace every a with pi over 3, replace every b with pi over 4. Okay, we go to our unit circle. Remember, tangent is just y over x. Just divide the numerators. Just ignore the denominator when you're looking at your unit circle. Okay, what's tangent of pi over 3? Yeah, square root of 3 over 1, which is square root of 3, right? Ignore the denominator. Just look at the top, y over x, root 3 over 1. Okay, tangent of pi over 4? Just 1. 1 plus root 3 times 1. Okay. Question with 2. All right, let's go to 3. So we don't recognize pi over 8 and 7 pi over 8, but maybe we can go the other direction. Maybe we can merge it into some identity. So it looks like we recognize this, right? Isn't this the one for sine of a minus, or sine of a, let's see, sine, okay. This is the one for sine of a minus b, right? Okay. Okay, replace the a. Well, it looks like our a is just pi over 8, our b is 7 pi over 8. So we get sine of negative 6 pi over 8, which is sine of negative 3 pi over 4. Okay, so negative 3 pi over 4, that's going to be in the fourth quadrant. Basically, is 7 pi over 4. Sine, it's going to be the y value, right? Negative root 2 over 2. All right, look at number 4. Looks like this matches nicely with the tangent of A plus B rule. Let me write that here. This matches nicely with so we can just, we don't recognize 80 and 55, but if we add them together, maybe that's something that we can recognize more easily. $135. Okay, tangents. It's y over x, negative 1, right? Root 2 divided by negative root 2. Okay, questions so far? Yeah, we're just simply going back and forth between our identities and just matching our rules. Okay, number 5, use identities to simplify. Looks like this is matching up with sine of A plus B, so we're just going to build it off of that. Oops, cosine A, sorry. Sine of pi is going to be 0. Cosine of pi is going to be negative 1. All we have left is negative sine of x. Okay, tangent of A plus B. Build that out. replace A with pi, B with x. Can't do much with tangent of x, but we can get something going with tangent of pi. Tangent of pi, y over x, 0 over -1, so that's just 0. Looks like the denominator is going to mostly go away except for the 1. I'm left with tangent x over 1, which is just tangent. Okay, next page. Try number 7 and 8, and I'll follow up with the steps. Okay, number 7, this matches nicely with cosine of A minus B. Cosine of 3 pi over 4 is negative root 2 over 2. Sine of 3 pi over 4 is positive root 2 over 2. Leaving in that form is fine. You can also decide that you want to factor out a GCF, factor out the root 2 over 2. Okay, try number 8. All right, number 8. This matches with tan of A plus B. Tangent of 7 pi over 4 is just going to be -1. Okay, let's look at number 9 here. Any questions so far? Okay. So direction says, suppose that A and B are angles in standard position. Use the given information to find sine of A plus B, tangent of A plus B. But we're going to have to build our ratios from triangles in the first, second, third, or fourth quadrant. Okay. So let's see if we can build out what's happening. Get all this information gathered before we jump into sine of A plus B. Okay, so let's figure out what we can gather just from that sine of A equals -3/5. Okay, where's angle A located? Between 3 pi over 2 and 2 pi, so that's quadrant 4. Okay, so let's do that. Let's see if we can put that information onto a triangle. Okay, fourth quadrant. Remember, whenever you draw a triangle, always involve the x-axis. Okay, don't ever involve the y-axis. Okay, sine is what? SOHCAHTOA. So opposites over hypotenuse. Make sure that you remember your hypotenuse is always positive. Okay. A squared plus B squared equals C squared. Pythagorean identity will help me get to the A value. Or Pythagorean theorem. In this case, it is an identity. So we're going to get B equals to 4. Okay, so once we have our triangle filled out, we know we can find anything we want. We can find sine, cosine, tangent. Okay. All right, so we'll put that off to the side. Let's build this here. Cosine of b equals -12/13. Which quadrant is this going to be in? Third quadrant. So let's build our triangle in the third quadrant. Cosine is SOHCAHTOA. Cosine is adjacent over hypotenuse. So -12/13. Pythagorean theorem. (169 minus 144 is 25. Square root of 25 is going to be 5. But this is in the third quadrant here, so this should be what? -5. All right, we have everything that we need. Now we can focus on sine of a plus b. Okay, so we just go to angle A, sine of A. Okay, throw that in. That's easy. -3/5. Cosine of B. Okay, that's easy as well. They gave that to us. Cosine of A. Okay, what's cosine of A? Yeah, SOHCAHTOA, right? Adjacent over hypotenuse, 4/5. Okay, what's sine of B? Sorry, I meant to put B here, not theta. Good, -5/13. This is 36/65 minus 20/65, which is 16/65. Okay. Tangent of A plus B, build that out as well. All right, what's tangent of A? -3/4, right? Opposite over adjacent. What's tangent of B? Yeah, 5/12. Opposite over adjacent. All over 1 minus. We already have tangent A, tangent B, so just copy those over again. Okay, it says no calculators, but we'll just use our, right. We have the answer. Just have to clean that up. It ends up giving us -16/63. So if sine is positive and tangent is negative, you guys know which quadrant that's going to be in? First is everything positive, right? Yeah, I think second. Second, sine is positive. Sine is the only one positive. We know everything else is negative, so must be second quadrant. Okay, one last one. Number 10. Let's build our triangles. Once we have our triangles populated, then the rest is just finding all those fractional values. Are we okay so far? All right, number 10. Cotangent of A equals 2/5. Let me. Okay, are we okay here?
Yeah, you just leave it at that.
Cotangent of A equals 2/5. We prefer to think in terms of what? Of tangent, right? I guess we don't have to change it, but just easier. So if cotangent of A is 2/5, then we can think of tangent of A as what? Yeah, just I find it more straightforward to think in terms of sine, cosine, and tangent if possible. So I'm going to say tangent of A is equal to 5/2. Good. Which quadrant is angle A going to be in? Third quadrant. Okay, let's build our triangle. Okay, 5/2. What do we put onto this triangle, though? Do we just say 5/2? Good. These are both negative, right? I mean, it's not showing the negatives because they're being canceled out. But it's actually opposite, -5, adjacent, -2. Are you guys okay with that? Okay, Pythagorean theorem gets you to your C value. Square root of 29. All right, so we have that from the first triangle. Let's find the second triangle. Tangent of B is -4/3. Which quadrant? Second. Opposite over adjacent, -4/3. Pythagorean theorem, a squared plus b squared equals c squared. That's just going to be 5. Okay, let's find sine of a plus b. All right, what's sine of a going to be? Yeah, -5/29, okay? Cosine of b. Okay, 3/5. Back to cosine of a. -2/29, adjacent over hypotenuse. Sine of b, what's sine of b? -4/5. Either this or rationalize the denominator. Okay, moving on to tangent of a plus b. Okay, well, everything is already given to us, so let's go a little faster, right? 5/2 minus 4/3. I got -1/2. Is that what you guys got? You guys confirm? Oh, wait a second. Should be. Oops, should be plus. 7/26? I think that should be right. Sine is positive, tangent is positive, therefore quadrant. Which quadrant? Yeah. Yes. Oh, if it's a fraction, it doesn't matter which one is which. As long as there's only one negative, it'll work out. It should work out the same way. Do you guys confirm that I got that? What my calculation matches yours? Anybody confirm that? 7/26. Okay. So quadrant 1, both sine and tangent are positive. Okay. Questions? All right. Let me check your classwork.